In this course, we will be creating APIs with .NET. Well, with ASP.NET Core to be specific. Remember, what was previously called .NET Core is now called .NET, but the web portion is still called ASP.NET Core, not to confuse it with ASP.NET based on the legacy .NET framework. But I digress. Let's talk more about building web APIs with ASP.NET Core in .NET 6. So why do we need such an API in the first place? The idea is that we have certain pieces of information, certain data, and we would like to share that and provide it to very different types of clients, such as web applications, mobile applications, native applications, maybe even desktop applications. And all of those clients should use a uniform contract, the same language, the same format, so to speak, to communicate with the API. And that's the whole idea, actually. So what that means is that we have an API, and that API stands between our server, our assets, so to speak, and all of the clients, the various clients that use one uniform way of communicating with us. And that's why we want an API. There are many things to learn when creating an API with .NET, but it's beneficial if you already know a few things. Not too many, don't worry, but well, since we're using .NET, any previous exposure to it would be beneficial. If you've been using .NET before, and I mean the thing that was previously called .NET Core, that's great. If you've been using the old .NET framework, you still know many of the basics that we require in this course. We will be using .NET 6 here. At the time of recording, that's the latest version and it's a long-term support version. Also, when we are writing code, C# is our language of choice. There are several languages supported by .NET, but C# is the most popular one, so that's why we picked it for this course. If, however, you are proficient in any other supported .NET language, you will still be able to follow along just fine. We are creating APIs or web APIs, and therefore we will also be using web technologies, especially HTTP. So if you had any previous exposure to HTTP, not just as a consumer using a web browser, but programming-wise, then that's a good thing. You don't have to know everything in and out about the protocol, because some of the more advanced and in-depth features will be thoroughly explained later. But still, if you know details about HTTP, it is helpful. Also, if you've already created APIs with the .NET framework or with .NET even, so if you've created ASP.NET Web APIs or ASP.NET Core Web APIs, then you will recognize many of the things that we are about to show and discuss. On the other hand, if you didn't, don't worry. I'll explain everything so that you can follow along easily. And with that out of the way, let's start creating our APIs with ASP.NET Core 6. Let's get started and dive right into creating APIs with ASP.NET Core. Before we do that, we need some software that facilitates what we want to achieve. The first choice, and also usually my primary choice, is Visual Studio from Microsoft. If you go to visualstudio.com, you'll get redirected to visualstudio.microsoft.com, and there you can meet the Visual Studio family with basically 3 family members. When I'm referring to Visual Studio, usually I mean the option on the left, the quote-unquote real Visual Studio. It's available in 3 editions: Community, Professional, and Enterprise. Community is free if you meet some prerequisites. So that includes individual developers and small companies. Have a look at the license requirements, and if you're eligible, feel free to use the Community Edition. The Professional and the Enterprise Edition, they are commercial, so you have to pay for them. If, of course, your employer or your company already has the license, feel free to use that license, obviously. It doesn't matter which edition you're using in terms of following this course, because everything we do works equally well with all three editions. Also, there's Visual Studio for Mac, which, as the name suggests, runs on a Mac. However, it's not Visual Studio. It's a different product. It looks very similar, but feature-wise, they are just different. The Visual Studio version, for instance, can also be very well used to create software that runs on macOS and iOS. You can do that to some extent with the Windows Visual Studio as well. But yeah, they're different products. But if you are a Mac user, then you can use Visual Studio for Mac. I'll be using Visual Studio for most of this course. However, the software we are creating runs equally well with other IDE options, including Visual Studio for Mac and the third choice. And that third choice is Visual Studio Code. Sounds like Visual Studio again, and logo or the icon is very similar, but still, it's a different product. It's a family member, but maybe the family member was inherited or we got them by marriage. And Visual Studio Code is an IDE that, well, runs under Windows, as it says here. But if you look closely, you'll see that it's also available for macOS and for Linux. So it runs everywhere. And it's free. Oh, and it's open source. So you see the 3 claims right there, right over the download section. So that's an open source project that is very well suited for creating ASP.NET Core applications, including web APIs, on every platform. And that .NET is running on every platform is, of course, an exciting factor here. So you can use Visual Studio Code plus the command line interface, the CLI of .NET, to create web APIs as well. And whenever there are differences between using the full Visual Studio and Visual Studio Code, I'll always mention that, of course. And then you can use that free IDE not just to create .NET content, but also for JavaScript-based applications, Python, C, C++, many other types of applications. So it's not tied to Microsoft technologies, and I see it in use almost anywhere, even in companies or at developer shops that do not use Microsoft products at all. So it's still a very solid choice. And as I already mentioned, no matter what you're using, you will be able to create web APIs with .NET 6 just fine with all of those options here. And there's also Rider from JetBrains, another commercial product, which is also an excellent choice for creating web API applications. Another software I like to use a lot, and you will want to use it as well, I'm pretty confident, is Postman, available from getpostman.com. It's a software that facilitates testing APIs. And yes, we will test some of our APIs during this course, and Postman will be used in many instances. And I'll talk a little bit more about Postman a little bit later. But this is basically what you need on your system, and of course, .NET. And then basically, we are ready to go. Without any further ado, let's create our very first web API with .NET 6 using Visual Studio. So I have Visual Studio 2022 here. That's the minimum version for .NET 6. And I click here on the start screen, create new project. I could also use the file menu and then new project. And then I get a list here of various project templates. I can filter by language, platforms, and also project types. So I could, for instance, say I'm only interested in web projects, which limits the choice a little bit. I can also search for something, so I could search for API. And then I'll get a couple of matches. So here, 2 for C#, ASP .NET Core Web API, and ASP.NET Web Application .NET Framework. The latter choice is, as it actually says here, for .NET Framework. So the old legacy runs on Windows only .NET. That's not what we want. So we want ASP.NET Core Web API, which sets up an ASP.NET Core application and prepares it for using an API. If you already have an MVC application based on ASP.NET Core or an existing ASP.NET Core Razor Pages application, then you could also add support for APIs. But here, we'll just start with one API, and we just use that template here. We just have to find a good project name. So how about my first API? That's the project name and also the solution name for Visual Studio. And then we can pick the framework version. Here we pick .NET 6 long-term support, latest version here. We don't need any authentication in that project. We configure it for using HTTPS. You do not want to enable Docker. And then there are 2 interesting checkboxes down below here. The first one is use controllers, and it says we should uncheck it to use something called minimal APIs. We'll cover that a bit later. So let's leave that checkbox activated. Also, it asks us whether Open API support should be enabled. And yes, we want that, and we'll actually see that in action just shortly. That's all we need to do. So we hit create, and then the template is used to create a new application. So basically, the template is a zip file with placeholders, and these placeholders are filled. So the my first API, for instance, is used as a namespace name now. We got a project, and that project has a program CS file and a weather forecast CS file. The program CS file is something you most probably already know from quote-unquote regular ASP.NET Core applications. So it contains information about, well, actually running the application. So it says here, we would like to have support for controllers. So that sounds like MVC. These 2 things were added because of this Open API checkbox, but we'll see that a little bit later. Yeah, and then basically we configure the HTTP request pipelines. So there's something that's happening in developer mode. We use controllers, so we map them so that we can access controllers via the associated URLs. We redirect to HTTPS, etc., etc. So that's basically the app. And then we have this weather forecast CS file. That's a simple model where we define a class called weather forecast with information like date, temperature in Celsius and 1 in Fahrenheit, including automatic conversion, and a summary. So basically, our model consists of a weather forecast. And then we have the controllers folder. And in that controllers folder, we have the weather forecast controller. And the weather forecast controller, and we'll have a look at the code in more depth later. But basically, it's a class, and there is a method called get. What that basically does is that it creates weather forecast instances, 5 of them. And well, using the current date and the next 5 days, using a random temperature between really, really cold and unbearably hot, and some random summary. That's all that's happening. So let's see what happens when we hit Control F5 to run the application, and then see what the output in the browser is. Here we go. The web application was created on localhost port 7170. That's a random port. So you might have a different port number if you're using the exercise files provided as part of the course assets. Then you'll have the same port number, but always verify that you are talking to the correct port number. And what you get here is a UI, a user interface for the API, because we have one endpoint now, /weather forecast, and we can call that endpoint here. So there's a nice UI. So we can say try it out, and then we can hit execute, and then basically the API is run. So we can try this. And so we get some nice JSON here, and that JSON contains random dates, temperatures, and a summary. So actually, that's okay, because when it's in the mid 40s in Fahrenheit or 8 degrees Celsius, for me it's chilly. But if it's even lower, no, it's not mild, right? So completely random, the values here. But this is just a UI that is only activated in development mode and makes testing those APIs quite convenient. But if you're actually consuming the API, what you're doing is you call it via the correct URL. So we use weather forecast, and we could also lowercase it. .NET is not picky here, and then we get the raw JSON data back. And this is how we create a web API in no time. And of course, we'll create more and better web APIs throughout this course. To sum up, here's what we had to do to get the API up and running. First of all, we had to create a new project in Visual Studio using the ASP.NET Core Web API template. And we also left the 2 checkboxes in the wizard activated. The second one, so that we got the nice UI to test our API. The created project had a controller, and the controller had a method called get. And that then contained the implementation to, well, basically create 5 totally random weather forecasts. And once we ran this in the browser showed us some JSON data with the information created in the controller. When you open up Visual Studio Code and look for File, New Project, you won't find it. You can open a folder or a file, but there is no wizard to create our ASP.NET Core Web API application. Well, at least not built in. Of course, I could go to View and then Terminal to access a console. In that case, it's PowerShell. And I can use that and the .NET CLI to create a project. But I could also do that from a separate terminal or command window, and actually that's the approach I prefer. I think it's just a little bit better to see. So I already created a projects folder here, and then I can do .NET new -- list to get a list of all of the installed templates .NET came with. And the list of templates and the number of templates may differ on your system a little bit depending on what you already installed. And there are several options here, but only one with API. ASP.NET Core Web API, and the name of the template is Web API. So that's what I would like to do. So how about we do .NET new Web API, and then we provide the output folder, which then also serves as the name for the solution and the project. And since we already did my first API, how about my second API? And then the first time this runs, it takes a little bit longer, but then the project is created, and now I could go into the folder that was set up for me, and then just say code dot, which would launch Visual Studio Code in the current folder, or I go to Visual Studio Code and then just say open folder, and then I just access the folder. So projects, my second API, and that's the folder I'd like to use. I'm asked whether I would like to trust the authors of the files in this folder. Well, let's just say I do this, because then I have access to all of the features. And what I see here looks pretty similar to what we saw in fully fledged Visual Studio before. We saw the program CS file, and it's the same content because it's essentially the same template. We have the weather forecast class as our model, and we also have a controllers folder, and in there we have the controller. We are also asked whether we would like to install additional assets. That happens the first time we are opening up the solution or the project. And I agree, that would be a good idea. So now everything is basically installed in the background. And then there are two ways to run this application. Well, at least two ways. We could go back to the terminal. And we are here in the folder of our application. And we could just do a .NET run or even .NET watch. Then the application would be refreshed every time we change something. Well, depending on what we change, but most of the time. Or we can go to the run menu, and then we can either start debugging or run without debugging. And I mean, I'm joking here, but debugging, that includes the word bug, right? And I don't do any bugs. I do a lot, actually. I'm just kidding. But I would say this time, since I didn't change anything, I'm confident that the code will just run. So we can do Control F5. And that basically runs a build. And again, the first time this takes a little bit longer than all the following times, at least in most cases. And once this is done, then the application will be run and the browser will open. I'm using a different web browser this time, a web browser that doesn't know the certificate for localhost yet, and therefore we get this warning, potential security risk ahead. And clicking on advanced, we get the reasoning, the certificate is not trusted because it is self-signed. And this is a usual approach actually for localhost, because localhost means something different to everyone else. Therefore, there can't be a globally accepted certificate for localhost. But we could accept it on our machine to avoid this error message, or we could, at least in that case, don't do this for regular public URLs, but for here, for localhost, we could accept the risk and continue to get access to HTTPS localhost random port number. Here it's 7252/weather forecast. And then when we do that, indeed, we get JSON back from the API, and since this is Firefox here, the JSON is even nicely formatted. But if you look at the raw data, it's the same structure that we already saw when using the other browser, which was Chrome, by the way, in the previous video. So the server returns the same data, well, since it's random, the same type of data, no matter whether we have created a project in Visual Studio or using the .NET CLI, and we're then, for instance, using Visual Studio Code to edit and run it. And essentially, it's the same code. So it doesn't really matter what kind of IDE we are using, because the templates come with .NET and the rest is just code we are about to tweak a little bit. One final word of caution: if the page here comes as blank, so if you don't see anything, maybe, just maybe, you were just using HTTPS localhost and then the random port number, but not the /weather forecast at the end. It's an API. We don't have a root page or an empty page that's just showing us information about the API. And the UI we had automatically created for our API is also not available as the root document. So it's using a different URL. So if that is the case, just check whether you have the correct URL. One of the features that were added in .NET 6 are so-called minimal APIs. We have already seen this checkbox when creating an API project in Visual Studio, where it says uncheck to use minimal APIs. And then when we run through the wizard, we get a minimal API. However, this can also be done using the CLI. So we could do .NET new web API and then -h for help, which gives us a list of all of the options. So much of the things you'll see in the Visual Studio wizards are actually options of the .NET CLI, including this one here, -minimal or --use -minimal -APIs, which creates such a minimal API. So let's do that. .NET new web API -minimal, and then output folder. How about my third API? Once again, we have our application set up for us. We open up our IDE. Yes, I trust the code. And now you see there is no controllers folder. The controllers folder is gone. There's basically just one file, program.cs. Wow. So while we are installing missing assets, let's have a look at the program.cs. At first, it looks similar to the regular one, but then we see all of the code from the controller. Maybe you remember this one. So we create 5 random weather forecasts like this. That's now all part of program.cs. So that's really minimal. Instead of having 3 files, we just have 1 file with here 43 lines. For demos, and I have to admit also for videos like this one, that's actually pretty nice because you don't have to switch between individual files to explain something. You put just everything in one place. But I think you might agree that the more complex an application gets, the more cumbersome it will be to pull this off. So I still prefer having a controller or even controllers for my various APIs. I don't like to put a lot of information in program.cs. There are a lot of settings in program.cs. The more an application grows and the more features and middlewares you're using. So personally, I don't want to add more to it, especially not concrete implementations like an API. But of course, your mileage may vary, so this might be a very viable option for you. So I definitely wanted to show you how this is done. After this quick start into creating APIs with .NET, let's take a few steps back and look at HTTP in a nutshell. This is the standards document for HTTP version 2, which is supported in all the major browsers. But from a protocol perspective, most of the concepts of the preceding versions, HTTP 1.1 and HTTP 1, they still apply to web applications today, and especially for APIs. This is confirmed when having a look at the specific document. Probably the most important sentence here in the HTTP2 specification is that this specification is an alternative to HTTP 1.1, but it does not obsolete it. And I would like to take a look at HTTP 1.1 and use that to explain some of the API concepts we are about to use. If you look at the list of people that are the authors of the HTTP 1.1 specification, probably the most famous name here is Tim Berners-Lee, the, inventor of the World Wide Web. And there's also a gentleman called Roy Fielding. We'll talk about him a little bit more in a few minutes, but let's stick with the HTTP protocol first. And the abstract section is pretty descriptive. So HTTP is an application level protocol. And now, probably one of the most important aspects. It is generic and stateless. Stateless means it can't remember anything. if you've created web applications before, you will know that, well, there are ways to remember something. You could use cookies or sessions based on cookies or other mechanisms, but HTTP doesn't really help you there. Cookies are not part of the specification, and instead, cookies are a separate specification that was created much later than HTTP itself. So we have HTTP, a protocol that is on the application level for hypermedia information, as it is stated here. Hypermedia basically means you have HTML with links, more or less. It doesn't necessarily has to be HTML, but you have to have links. But well, we have a generic protocol, which is actually text-based, and there are several features that are part of the HTTP protocol. One that's pretty interesting is the negotiation of data representation. So data is being transferred via HTTP, but the representation of the data can be negotiated. So imagine you have a list of products and you would like to use HTTP to get the list of products. Then you can tell the server in which format you would like to have those products, because that's still the same data, no matter whether it's JSON or XML or something else, but you can negotiate the data representation. Looking at the table of contents shows you that there are a lot of pieces of information and descriptions, and it's a very long specification, although HTTP itself looks relatively simple, but there are some aspects which are maybe more important for us now than others. There are HTTP methods, 8 of them in HTTP 1.1, later versions have more, and we will use them for our APIs. There are also status codes, which are part of the HTTP response, and we'll also need them. Well, not all of them, but many of them. And then there are some specific headers which are used throughout the specification, and we'll also use some of those headers. And one feature that is supported by those headers or enabled by those headers is this content negotiation, which I already mentioned. So there's a lot of stuff in the HTTP specification, but we don't have to understand it all. We just have to remember that HTTP is very well suited for usage within APIs. Clients readily support it, and most use cases for APIs can be done very easily with what HTTP has to offer. We'll use some of the aspects of that specification, and we will use a concept called REST, which is actually hidden in this document, and we'll talk about that next. Do you remember the name Roy Fielding, who was the person at the top position in the credits of the HTTP 1.1 specification we previously had a look at? Well, that Roy Fielding got his PhD from UCI in 2000, and his dissertation was called Architectural Styles and the Design of Network-Based Software Architectures. Chapter 5 of his thesis was called Representational State Transfer, or REST. And you'll see the chapter introduction right here. And this REST principle is the basis for many, many APIs out there. Sometimes REST is a rather, let's say, religious topic where some people have very, very strong opinions. I mean, everyone is opinionated, including me, but some people are more opinionated than others. Let me put it that way. I try to handle this as pragmatic as possible, because there's not one wrong and one right, or many wrongs and one right. Some people just have different opinions. I do have some points which I would like to make clear. First of all, REST isn't a technology. It's a design concept. It's a programming paradigm. And the idea is that REST is using existing infrastructure. REST is built on top of HTTP, because HTTP, as I mentioned before, comes with many features that are really, really useful, including for APIs. The basic idea is that we are using URIs, Uniform Resource Identifiers, to access resources. So URIs provide access to some kind of resource. And another aspect is, in which form would I like to have the information about that resource, or what do I want to do with that resource? Read it, write it, etc. That's something that comes from HTTP as well. It will not be part of the URI. We will use other measures. For instance, HTTP headers or HTTP methods. To give you an example, for operations like retrieving information, writing information, updating information, specific HTTP methods will be used. Again, we are reusing existing infrastructure. Although REST is flexible in many areas, Fielding defined 6 architectural constraints when working on it. And although I do not really want to go far into the philosophical space here, I think it's important to know about them. First and foremost, RESTful APIs need to have a uniform interface. So we just need to have one URI per resource, and well, the interface has to have a uniform look. There are several approaches how to achieve this, and one thing Fielding recommended was something which is spelled HATEOAS, an acronym for Hypermedia as the engine of application state. Yeah, I know that's pretty long, and it comes with a couple of extra demands, including that the representation of each resource should contain specific links pointing to, let's say, things that you can do with that resource. For instance, if you have a category of items, and each category of items contains a list of items, the representation of the category could contain a link to the list of the items in that category. So that's one of those aspects, but we'll probably do it rather lightweight in our course. Next up is client-server. Well, client-server means client-server architecture, with the client and the server being independent from each other. A client may evolve, a server may evolve, but that should not render the API useless. That is something that can be ensured by having a contract between client and server, and that contract is adhered to. Also, that's the third item, the API should be stateless. If you consider where Fielding is coming from, HTTP is stateless, so APIs should be stateless as well. Also, the API, or the data retrieved from the API, should be cacheable. Retrieving a list of items, for instance, is something that could be cached. Changing an item or adding a new item is something that should not be cached. And HTTP has support for caching, as we all know. Also, a layered system architecture is something that REST needs to support, but I think that's obvious. We have several layers in a typical web application anyway, so that's a no-brainer. And finally, we have something called code on demand. Fielding wrote specifically and said, yeah, this is optional, but the idea here is that when you return data, you could also return code that then can be executed by the client. Turns out, JavaScript is something that actually does that in the web. However, we will not use something like this in the API. So these are the 6 constraints according to Fielding. Of course, you might find a lot of aspects from HTTP in them. Again, think of where Fielding is coming from. But the idea is, once we actually write our API, you will specifically see many of those aspects right in our application. There are so many approaches to API design, so many best practices, naming standards, and of course, personal preferences. I do have my preferences when creating an API, but you may have or develop your own. This course is on .NET and web APIs with .NET, so I don't want to force you to a specific style. I want you to learn how web APIs with .NET 6 work. Therefore, I tend to handle things rather flexibly. However, there are some best practices that most people agree upon. I would like to briefly cover those. The APIs we are working on will be for the fictional H+ Sport brand. You see the fake website here, h+sport.com. Well, the website is not fake, but the company does not exist. But still, you can navigate around. You can't order anything though, but there is a shop. Let's have a look. The shop features a couple of categories, so activewear for men and women and some other. And then you can just go into one of those categories and have a look at the available options. So this looks nice. And then you can choose a size and a color and then add it to the cart. And the model for our APIs will be the inventory of that shop. So we'll have categories and we'll have items in those categories, because that gives us a lot of things to play around with. But back to API design. When we set up the URIs that represent the resources in our shop, one common aspect that many agree upon is that we should use nouns, not verbs. Verbs indicate an action, but actions in REST are denoted by the appropriate HTTP verb. So we are using nouns. So how about this URL or this URI, which will give us a list of products, all of the products that are available in the shop. So we have the server name api.h+sport.com, and that server name does not exist. I'm just using it as an example here. And then /products. We are using HTTP GET by default as the HTTP verb, and that also indicates that we want to retrieve information. We don't want to add products yet. Now, when I would like to access an individual product from the list of products, how do we do that? The most common approach is to do something like this. So we have /products and then /the ID of that product. It could be an integer, it could be a GUID, could be a string, depends on your data model. But basically we use /products to access all of the products and /products/ID to access one individual product. Now some of those products, they may have sub-properties. For instance, for clothing, we can have different variants, sizes for instance. How can we model them? Here's one suggestion. /products/123 gives us the product with the ID 123. /variants, then appended, gives us all of the variants for that specific product. And you probably already guessed it. What happens if I would like to take a look at one specific variant for one specific product? Gotcha. /products/123/variants/ and then the ID of the variant. And that's the approach we will be taking. Now this is all for retrieving. But what if I do not want to have a list of products? What if I want to add a product or to update an existing product? That's when HTTP verbs come in. There are some subtle differences how you could do this, but in general, get is for reading data, post is for creating a new item. So you would post to /products. Put is updating an existing item. So you would put to /products/123, and delete would delete an item. And that's how you map HTTP verbs to actions that should be taken. But those actions are usually taken on a specific item or on a set of items. And that item or that items, they do have a uniform URI. So this is what the REST principle is all about. There are many options how to test your API. And the good news is, it doesn't really matter what you're using, at least with regards to being able to follow this course. However, I do have some preferences, and I'd like to share them with you. One thing I already mentioned is Postman from getpostman.com, which is a very powerful yet very flexible tool, especially for advanced features. Here's the URL we previously used when we set up our sample application from within Visual Studio. And of course, you could also use the Visual Studio Code URL or whatever port number you have. I just copy the URL to the clipboard and then switch over to Postman. I create a new request. I can pick a couple of HTTP methods here, but get is what I want. And then I see some of the headers that are being sent. I could also add my own headers, authorization information. I could also add a body, but we are not sending anything, we are retrieving data. So this just will do. And then I send the request and get the data back. And not only do I get the data, it's prettified so I can see it in a structured way, but I can also have a look at the raw version, etc., etc. I see the HTTP status code. So 200 means everything has been okay, and we will see others too. And this makes Postman a very, very powerful tool that I really like to use on a regular basis. If you do not want to install actual software, or if you just want to check whether the request has been sent and which data came back and how the headers looked like, the browser actually might be good enough. All modern browsers have their built-in web dev tools. Sometimes they're called browser dev tools, sometimes also the F12 tools, because on most systems, the F12 key is what opens up those tools baked into the browser without any extra installation. Going back to the browser where the API endpoint is already open, I can hit F12, and sometimes I get this extra box down here in Chrome when there has been an update. So we just have to close it so that we get the full view of everything. And then I do Shift and hit reload, because then I do the request again without caching. I see the HTTP request here and then see all the headers that were sent as part of the request. I see the headers that were sent as part of the response. I can have a look at the response and get some other information like how long did it take, etc. But basically, I see all of the headers, and I can also right click on this, and then I can save the request so that I use it later. And I can also have a closer look at specific headers. I can rerun the request and some other features as well. By far not as powerful as Postman, but many common operations like, do I get data back, which headers were sent, which headers were received, the browser dev tools are a fine choice. Not only here in Chrome, but also in all other Chrome-based browsers like Edge and Opera, and of course in Firefox and Safari and others as well. There's one more tool left, which I'd like to show you, my dark horse, so to speak. It's been quite prominent for a while, especially among users of Microsoft technologies, and before browsers had their built-in web dev tools. I'm talking about Fiddler, which is now part of Telerik. Fiddler is a proxy which is installed between the browser and the web application. So all the requests to the web application now go through Fiddler and therefore can be intercepted and analyzed. I hit refresh again and get the information that the connection is not private, because now we are going through Fiddler. So I say, yeah, that's fine. And then we can go back to Fiddler, and we'll have to look a little bit and wade through the noise here, but this is the request that we wanted. I have to be quick to get it. And again, we see all of the headers that were sent. We see the data coming back. It's JSON, so we see the structure here and many other pieces of information as well. Again, we can start playing with the request. We can resend it. We can change headers and therefore have a very detailed view at what's going on, and can also manipulate those requests. But again, using a proxy might not always be the best choice on a local system. So I'd rather go with Postman or other specialized software. In this chapter, we will start implementing the API for H+ Sport with the easiest use case there is, probably, retrieving data. You remember the API we basically took from the template in Visual Studio, or we let the .NET CLI create it. There were a couple of things that are noteworthy, and we will have a closer look at them when we return to the IDE. But the most important aspects first. We had a controller class, and that controller class inherited from controller base. You may be aware that ASP.NET Core supports the MVC paradigm and provides an MVC, Model View Controller framework for web applications, ASP.NET Core MVC. And the controller there basically handles user input and HTTP requests and then, well, takes care of all of the rest. It's the same approach when working with APIs. So we have a controller, or we have several controllers, and they handle HTTP requests and take care that the correct data is returned by them. We have also briefly seen minimal APIs where we do not need a controller, but so far we will work with controllers. Then this controller class needs to be adorned with the API controller attribute. And that adds some convenience features, so many things that are very important for APIs just work out of the box. For instance, content negotiation, or that data is properly serialized out of the box just by using the API controller class attribute. Well, and then within the controller, we will have a couple of methods. And we have already seen that HTTP methods are very important for APIs because they tell the API what to do, reading data, writing data, etc. And the idea now is this. I could have methods that are called like HTTP methods. So a get C# method in our controller class would then be responsible for GET requests, and a method called post would be responsible for post requests. Also, if those method names just start with the HTTP method, it would work. So a method called getProducts would also be responsible for HTTP GET requests. But to make things really clear and to be explicit, you could also add an attribute. HTTP GET basically marks a method as responsible for GET requests, HTTP POST for POST requests, and similarly for all of the other HTTP methods we would like to support. That's basically all we need to know. So let's switch over to Visual Studio. Of course, you can use the .NET CLI equally well, because all we are doing is we just create a new project, once again using the ASP.NET Core Web API. And I'll call the project H+ Sport.API, but I'll call the solution just H+ Sport. This might allow me to add more meaningful projects to that solution later, if I feel so inclined. And I leave all of the other options with their default settings. And then it creates my new project. Looks exactly like the previous starting project we created. So we have the very unrealistic weather forecast service. And since it's so unrealistic, I just get rid of it. And I'll also get rid of the controller class here. Instead, I create my own. So I do add, and then nothing happens. Well, I get Razor component and the standard items here. But if I wait for 1 or 2 seconds while Visual Studio is initializing, and then try again. So I right-click on controllers, then add, I get here the controller wizard. Of course, you could just add a new C# class in here and then add everything that's needed for an API controller. But when using Visual Studio, that's just a little bit more convenient. Do note that the MVC controller node is pre-selected here, and that's not what we want. We are working with an API. So go here, and then we can choose between an empty API controller, an API controller with read and write actions already built in, and an API controller that even adds support for entity framework. And I would say an empty controller is just fine because we are about to add our own custom functionality. So I click add here, and then I use the name of products controller. I use the plural here because, as we will see in a bit, the name of the controller can be part of the URL. And remember our API design guidelines. So we are using nouns and we are using the plural. So products controller, CS class, and then we get the products controller class inheriting from controller base. And it is using the API controller attribute. So it's an API controller with some functionality built in. And then I can add methods. Remember, methods and controllers that then react upon HTTP requests are called action methods. So I add an action methods, and I'll start with public void because then I can skip doing any real implementation. So how about get products? That method name starts with get. So it will be called when an HTTP GET request comes in, but I can also be explicit and use the HTTP GET attribute here. That's basically it. But of course, we don't know what to do with it because there is one more ingredient missing. The missing ingredient, or one missing ingredient, is routing or routing, depending on where you live. Which URL maps to which endpoint, which method or action method in which controller. There are, of course, several ways to achieve this, but the one I prefer is just to use attributes. Here is a simple example. If we have the route attribute and we use it like this, route/products, then basically we say use /products, so localhost port 12345/products, to call this very specific method. For instance, to retrieve all products. If we would like to have parameters as part of the URL, and there'll be more on that later, we could use this syntax. So use root or route/products/ and then ID in curly braces. And this marks ID as the placeholder name for what follows in that part of the URL. So /products/42 means that ID has the value of 42. And that ID is then a parameter for the action method. So we would have maybe an action method called getProduct, and then in parentheses, int ID or string ID, depending on the data type. And that would be filled automatically with the data from the URL. If you would like to have optional parameters, the syntax kind of looks like the one you already know from C# and other languages. So just add the question mark, and then ID is optional. And so the data type in the action method is not, say, int, but instead nullable int. There are other specific types of placeholders possible as well. Here you see one example. If we have square brackets, then that's a specific placeholder, and square brackets controller is the most common one, and that's already used in the template, and it means the name of the controller. That's not the name of the class, it's the name of the controller, which is the class name minus controller. Let's have a look. Our generated controller uses the root attribute here on a class level. So this is the root for the whole class, and it's API/controller. Our controller is called products controller, so the root is API/products. I could, of course, also put routing information here on a method level. But for a RESTful API, remember, a resource has always the same URI, but HTTP methods tell the system what to do. So retrieving or adding a new one. So in many cases, just having a specific route, a specific URI for the whole controller class is a good idea. Actually, let's try this out real quick. Or should I say quick and dirty. So I would like get products to return something. We still do not have any products yet, but how about I just return a string, and the string is just okay. That's valid. It's probably not recommended, but it's valid. And we can run this in the browser. Here we go. We get the starting page with our /API/products call. So you already see the correct URL, but I could also type it in here manually. It doesn't matter whether you use uppercase or lowercase or mixed case, at least here for the URIs. And then if I run this, I indeed get OK. And it's a bit hard to see, but we have here OK in a listing font. So if we have a look at the network tab, we run this call, have a look at the products call, and then just pull this way up. Then you see, oh, content type is text/plain. So there's no JSON involved, because in JSON we would have had double quotes here. We just got text. And this is something that needs to change, but you see how the URI now maps to an action method. Instead, if you just go to localhost port, in that case 7233, and hit enter, then we would get 404 not found, because we do not have a starting page. Before we actually start implementing the API, we have to set up our data model. The API is for H+ board, so you see here the H+ board shop, and there are categories, and in each of those categories we will have a couple of products. Of course, the data model for that shop is a bit more complex, so there are different variants of some products, and there will probably also be users, and those users can order items. But so far, for our first experiments, I think that categories and products are good enough. So let's switch over to our IDE, where we will add some C# model classes. I first add something else, a new folder. I call it models, but the name is arbitrary, of course, and in there I'll put the model classes. So let's add a new class, and I start with the category class, which will hold the categories, or represent the categories. For holding the data, we will have a database a little bit later. We'll be using Entity Framework, so we need a key. So I start by adding an int property called ID. And then each category will have a name. And actually, that's already auto-suggested here. So yeah, I'll just accept it. If it's not auto-suggested for you, then you need to roll it manually. And I also get this null check warning that I could have a null value here, but I have to assign a value. I could use something like string.empty in here. But on the other hand, I will create all of the categories, and therefore I do not really need that default value. I'll leave it in, but it's not definitely necessary. So this is a category, which is actually pretty easy and simple and straightforward. And the product will contain a few more pieces of information. So let's add the product class, again starting with an integer ID. Of course, you could also use a GUID and a string. And yeah, a name is a good idea, but what the H+ Board shop also had was a SKU as a string, the name, and then also, let's say, a description for the product, and of course a price. And the price, I think, is something I'll use decimal for. And also an item could be available or not. So I add a Boolean property called is available. Right. And again, I could do the default values here, just to make Visual Studio happy. Also, a product belongs to a category, right? Category has an ID, and I could then just add the category ID as another property of my product class. And of course, when I have a look at a product, I may want to access the product's category. So for instance, I possibly want to create a list of all of the products, and next to each product I would like to output the name of the associated category. So I have to find a way to access the category, and I could do public virtual category. However, there's a catch. Imagine we have a product, and later this will all be serialized. So I have a product, and the product has a category, and the category has products, and each of those products has the category again. The category again has products, so we have an infinite loop. That was not a problem back in the days when Newtonsoft.json was the main package for JSON serialization and deserialization. But when that changed, or at least the default changed to Microsoft's own implementation in the system.text.json namespace, this changed a little bit. So we have to tell the serializer that this category property should not be serialized. And this can be done by adding the JSON ignore attribute, which, as control dot will reveal, is defined in system.text.json.serialization. All right, so now I can have a look at a product and then can also get information about its category. And a similar thing should also be done in the category class. So I could also have a public virtual list of products. Then can specifically work with those products. So I access the category, and then from the category I get a list of all of the products within the category. And of course, I once again have to either provide a default value or I have to remove the semicolon here at the end. And I'll leave this empty because in our model, each category will have at least one product. And so I can't fall into any null traps. Well, at least for now. That being said and done, we have now a category class and a product class, and they are linked to each other. So the model is there, the data is not, and that will come next. After creating the model classes, the next step will be to add Entity Framework to the project, or Entity Framework Core to be precise. So we are using Microsoft's Object Relational Mapper, or OR Mapper, and that will provide us with an API to work with so that we don't have to write any SQL to communicate with the database. Entity Framework Core does all the magic. We just work with our model classes. That's just the easiest way for us to get the data model into a usable form. So we have the model classes. We will need them, and we have to create a context class for the model classes. And then we have the model, but still no data yet. And as I mentioned before, we will start with reading data, not with writing data. So we have to seed our database with some sample data. The Visual Studio IDE has the NuGet Package Manager and allows us to easily install packages. So if we look for Entity Framework, then, well, we find Entity Framework, but more interestingly, we find Microsoft.Entity Framework Core and some other packages. So that's what we want. That's what I would like to add to the project and could do it with a simple click. But if you're using the .NET CLI, it doesn't really mean you're out of luck. You just have to do something else. And here in Visual Studio, actually, I can access the NuGet Package Manager console, which is basically a PowerShell. And I'll do it in here, but of course you can also do it from a regular PowerShell window. And if I increase the font size a little bit, I could do something like install.package and then microsoft.ent, and then I hit tab, and then it basically queries all packages that start with that name, and NT Framework Core is what I want. So let's install that real quick. And next, I'll also install Microsoft.entity Framework Core in memory, because that allows us to create a database that just resides in memory. So we are not dependent on an SQL server instance somewhere or any other database. We just have everything in memory. Of course, that means once we stop the application, then that memory database is purged. But to implement and try out the API, this is just a very convenient approach. So that's what we are doing here. After this has been done, I can finally implement the context class, which will be used to communicate with Entity Framework. So I'm adding a new class here, and I will call that class shop context, because it basically represents my shop, or the H+ Sports shop. And that shop context class derives from DB context, and DB context comes from Microsoft Entity Framework Core. And in that class, there are a few things to be done. So first of all, I'm defining DB sets. One for all of the products in the database. And of course, also one for all the categories in my project. And then there are two more things to do. First of all, after moving this within the class, I have to implement the constructor. So public shop context, and this is receiving DB context options. They're injected. And I'll just call the base constructor. So just that this is done. And next, there is a method called onModelCreating. OnModelCreating is, as the name suggests, run once the model is created. And I would like to inject something in there. So there's a model builder. And here I have to tell the system how products and categories are related to each other. So let's use the model builder and then the category entity. And one category has many products. And each product has exactly one category. And also the foreign key is the category ID. So this is the setup. This is how they are related to each other. And then I can call modelbuilder.seed. Modelbuilder.seed is filling the database with sample data. And you see, we don't get an error message. Where does that seed method come from? Is there some magic built in? Well, not really. I did build some magic in, because also in the exercise files you have access to, I added model builder extensions and extension method, and this extension method, well, basically adds 5 categories and then, well, almost 36 products for all of those 5 categories in total. So we have some sample data to play with, and these are exactly the products you see on the h+sport.com website. So this is how everything is tied together. This is my database context. So the one thing remaining is I have to tell the application that. So I go to Program CS, and then I will add something to the services collection. In previous versions of .NET, so .NET versions prior to 6, they had an extra file called startup CS where all of this was done. But starting with .NET 6, by default, this can be put into program CS. So that's what I'm doing here. And what I'm doing is I add a DB context for shop context. And shop context comes from my models. And there are some options which I can set. And actually there's only one option I would like to set. And that option is use in-memory database. And the database needs to get a name, and that name is shop. And after fixing that typo, I can basically end this. I just have to hit Control dot so that Entity Framework Core is used in here as well. I could make it a bit more pretty by putting this into a block like this. I prefer it that way, although it's not necessary here. And now, when I access the shop context, automatically Entity Framework Core kicks in. It's using an in-memory database, so all the data is only stored in memory, and I can work with my products. It's now time to create our first real API endpoint, one that returns several items. For instance, all of the categories we have in our system or all of the products we have in our system. There are different approaches how to achieve that, and the first one that I think is the most intuitive one is this. We have a method which is responsible for HTTP GET requests. So we have the HTTP GET attribute, the method name starts with GET, and it just returns a list of the products. So DB is our database context class. This gives us the list of products, and we just convert it to an array or to an INumeral. So the method just returns a list of products, basically. And this list is then automatically serialized into JSON, as we'll see shortly. We go to our products controller, and in the products controller, it's this method we would like to change, and actually I would like to rename it. I'd like to call it get all products so that it's obvious what's happening here, and it doesn't return a string any longer. It returns an INumerable of product. And product comes from Edge plus Board API models. And then of course it can't return OK, but we'll see that in a second. We have to create the constructor of the products controller and set the database context there because it will be injected. First I create a private read-only shop context underscore context, and then in the constructor, so public products controller, we automatically get the shop context injected, and then we just set context to context. And there's one more thing we need to do. We are seeding the database, and we have to make sure that this seeding takes place. That's not very obvious, but let's not forget it. So we do context database and then ensure created. And this actually runs the seeding if that hasn't taken place. And with that, we then just can do something like this. Return underscore context dot products dot to whatever, array or list. And then we are done. So when we compile and run this API, you'll see that we get our UI again. We have the API products endpoint, and actually let's try it out right here in the browser. So this is seeding the database, and then we get a list of all items that we have, all the products, all 33 of them. Right? And this comes from the in-memory database. And the serialization into JSON happens automatically. So no extra work to be done. and with very little effort, we have created our first API endpoint that does return something meaningful. The second approach to return something from our API is to use the return type action result. That's a type that basically means, okay, this is an action method and it returns something, quote unquote. There's one change in the implementation. Well, two changes to be exact. The return type of the getAllProducts method is not IEnumerable of product any longer, but action result or action result of IEnumerable of product. Therefore, we cannot do a return and then the list of products. Instead, we can do return OK of products. So the list of products is now an argument to a method called OK. And that's defined in controller base, actually. And OK here also happens to be the textual description of the HTTP status code 200, the regular status code if everything worked as expected, more or less. And the OK method means return the HTTP 200 status code, 200 OK, and in the payload of the HTTP response, send these products or these values. And you see where this is getting at. Of course, there will be other methods that then return different HTTP status codes, especially for error conditions, something like not found. And if you want to do that and have an easy approach to achieving this, then using action result is a good idea. There are more specific types of results, for instance, a JSON result, which is, well, JSON, or a content result, which is string, but basically action result as the most generic type here is a fine choice. Let's update the controller. So we just use action result here. We could use the type, but we don't have to here. And instead of just returning the products, we return OK. And then the products are the argument. And that's it. No other changes. And this time we will call the API endpoint directly. So we do API/products. And then we get all of the data in JSON format. And you can also see that this call here did return HTTP status code 200 as expected. When returning just one item, technically there doesn't seem to be a difference. We just return one product instead of a list of products. However, we should probably tell the API which product we want. Remember, when we were talking about API design, we suggested a URI like this, /product/ and then the ID of the product. And we can reflect that in code. So we are using the HTTP GET attribute. Also, we are providing a route, for instance, /products/ and then the placeholder in curly braces, like ID. So when calling /product/ 42, ID is 42, so the getProduct action method we are implementing receives the ID parameter and then can use this to find the product of choice. And of course, the route we are choosing depends on us, it's our choice. We have the API/prefix in our controller, so maybe let's stick with that. And then we can implement it that way. We return an action result once again. If we do not want to return an action result, but just the product, so if we just assume we'll have HTTP 200 every time and no errors, then we can also implement the getProduct method as one that returns product and not action result. In our IDE, let's add the new method. So it will be public action result and then getProduct. And we will receive an ID parameter as an integer. And then we just retrieve the product as context.products find ID, which returns the product or null if not found. And then we just return OK of product. So far, so good. We then can add the HTTP GET attribute. Then we could add the route, either fully qualified like API, products, and then curly braces ID. Or we could just use the ID because we have the base route on the class level. Or, and that's a kind of nice abbreviation, I just use this and put it into the HTTP GET call. So I put the route fragment, so to speak, in the HTTP GET attribute here. And so the ID attribute will be properly set. So when going to the browser, you will see that the UI now shows the additional endpoint /API/product/ID. And when I hit try it out, I can set the ID argument. So I set it to whatever, 30. And if I execute it, then I get one item, and the item has the ID of 30 with HTTP status code 200. And what happens if I do 42? We get 204 undocumented, and we get nothing. How can we possibly get nothing? Well, in the code, we look for the item with the ID 42, but we only have like 33 items in the database. So we didn't find anything, so null is returned. That's okay, but I think we are in dire need for some proper error handling. So we got the HTTP 204 status code. And if we looked that up in the specification, we would find out that 204 stands for no content. And that does make sense. There is no product with ID 42. And therefore, nothing, literally nothing, is returned. And the status code for nothing is 204, no content. So that's kind of correct and okay-ish, but I think we can do better, and I would like to show you how. So here's where we are at. We have our getProduct method, and we just look for our product, and then we return it with the HTTP status code of 200 using the OK helper method. But what do we do if there is no product with the ID of 42? So if product is null, from a REST standpoint, we should denote that error state with an HTTP status code. And the HTTP status code for I can't find something is, of course, 404, not found. How can we return HTTP 404? Well, there is the OK helper method for 200, and there is the not found helper method for 404. And there are other helper methods for other error conditions. So for instance, HTTP 400 is bad request. And of course, there's a bad request helper method. And there are also helper methods that help us provide a specific numeric status code. But this is a very common and very useful pattern and makes our API a bit more RESTful by just returning 404 if something cannot be found. Let's try that out. So if our product is null, then we just return not found, and the not found method returns a not found result, which also is an action result, and therefore this compiles and this works. So when we launch this in the browser, we will see one notable change, and actually I'll enter the URL right here. So API products /42. But first I activate the network tab. I hit enter, and we indeed get HTTP 404 here. And actually there's content. So even though I just get the information, there's nothing in there, I get some content. So I get JSON information, including the status code 404, the textual description not found, and also a link to a specific part, section 654 in some standard. So let's have a look. And indeed, that's the HTTP specification where 404 is defined. So we are linking to a kind of description of the error state, and that happens automatically. The value of this, at least in this specific scenario, is rather small because, well, we know that 404 means not found, but it's a uniform structure that is created also for some other HTTP status codes or error conditions, and just shows us what we get out of the box automatically by using ASP.NET Core Web API. And when we work on our API some more, there will be areas where there might be error conditions happening, and for all of those we will make the API behave appropriately and then return the correct HTTP status code associated to the error condition that occurs. And finally, since we are working with the data store so much, we may want to make our actions asynchronous. That's a rather easy task, thanks to what .NET offers us. All we need to do is change the method signature. So instead of public enumerable of product, we can do public async task of enumerable of product, and then use the await keyword, because now we are not using toList but toList async, and then can also use the asynchronous streaming .NET supports. And in case of using action result, we now have to use public async task of action result, and again use the await keyword when we are calling toList async, and that converts our API into an asynchronous one. Let's add this to the API real quick, and I really mean real quick, because it's just a few steps and always the same steps. So instead of doing public action result get all products, we just do public async task of action result, and then we return OK of await, and then context products to array async. So this is the first step, and this is part of Microsoft Entity Framework Core because of the async streaming. So I have to add this now. And next, here in the get product method, we also do async task of action result. We call find async, but we await it, and then in the end we just return OK of product. And that's it. Now, with just very subtle changes in 4 lines in our API, the API is now using async features, and .NET makes async really easy with async and await. And depending on the API and depending on what the API is doing, there can be some real performance benefits, especially under higher load. In this chapter, we will finally change the data in our data store. We will be writing new items to it. Remember, as of now, we are using the in-memory database, so when you restart the application, the data's gone. Keep that in mind. And don't wonder if the things you just added vanish after you do changes to the application and restart it. That being out of the way, let's start. And since we are now writing information to the data store, we have to expand our arsenal of HTTP methods we are using. So far, we've been working with the HTTP method get. Get does not change the state of the application, according to the REST principle at least. So when we add something to the database, we have to use something else. The main HTTP verb to do this is post, because that allows us to send data to the application and is also allowed to change the state of the application. Post is exactly what we want to use here. When we are updating data, we could also use post, and I know a number of large applications that do that. One of the reasons is that GET and POST are available everywhere, and even the most fine-tuned firewalls let POST requests through. Purists, however, say, no, you shouldn't use POST for updating information. Instead, you should use PUT, because PUT, just like GET, is idempotent. That means when you do the same PUT request over and over again, the effect is the same. It doesn't really matter whether you do the same changes 10 times or just once. Same with GET. With GET, you read information from the database, so you don't change anything there. It's different for POST, because if you add a new item and do this 10 times, chances are you have 10 new items. I'm aware that's a subtle difference. And still, usually updating is done via PUT. So to just have a distinction between creating new data and updating existing data. And finally, eventually, we would like to get rid of some items in our database. And that's what the delete HTTP verb is for. And as the name suggests, it deletes existing data. That's all we need to know. And with those HTTP methods, we can now complete the CRUD functionality of our API. CRUD meaning create, read, that's what you already did, updating and deleting items. While implementing our API, we've had at least one instance where our action method expected an argument. And in that case, that argument came from the route. But of course, arguments can also come from other sources, other parts of the HTTP request, for instance. And there are a couple of options, and I would like to show you the most important ones. There are more, but these three are probably the ones you will be using most often. First, there's from body as an attribute. As the name suggests, the data there comes from the body of the HTTP request. What's that? An HTTP request consists of HTTP headers and also, optionally, an HTTP body or a request body. So after the headers, there will be an empty line and afterwards data. And that's what from body does. From body makes crystal clear that this data that's part of the HTTP body or the request body should be used and bound to the arguments of the method. And we'll see that in action really shortly. It also works for complex types, by the way. So it doesn't just has to be limited to, say, integers or strings or other primitive data types. The next option is from route. So if you have a routing template, then you might have placeholders in there. You have seen that when we were using the ID in the URI and bound that to the ID attribute of the action method. We did not use from route there because Web API was clever enough to do that. But I'm always a big fan of being explicit there. Because what happens if there is an ID in the route and an ID in the HTTP request? So better make clear what your source is, and from route is basically doing that. And finally, we have from query, and that's data from the URL, from the query string, thus the name. Again, these are probably the three most important options, but there are more. But with those, you will come very far, because then you can accept data from the HTTP request, and usually that means a post or a put request, or from the route, you've already seen that, or from the query string. We are now ready to add a new item. In our application, we could add a new product to our data store. We need an action method. That action method needs the HTTP post attribute because it will be responsible for post requests, and its name is post product. So we start the name of the method with the HTTP method we are using. The argument for that method is of type product. Basically, ASP.NET Core Web API assembles a product out of the individual values that are sent as part of the HTTP request. You'll see that shortly. In the implementation of that method, we have to access our database context and the list of products there, and then just add a new product because we already got the product thanks to the model binding features of ASP.NET Core, and here ASP.NET Core Web API. This is not persisted to the data store yet. We have to call save changes, and since we're using an asynchronous method, we're using the asynchronous save changes call here and have to await it before we are at the end of the method where we need to return something. So the method is of type task of action result, and therefore we could just return HTTP 200 OK. But remember when we talked about the principles of REST. So when adding something, what we could do is that we provide an information with the URI to the newly added element in our data store. We are saving a product, and that product does not have an ID yet because we are not providing the ID as part of the call to the API. The ID is generated automatically by the database, but we still have the product, the variable product, which will get updated after saving into the data store with the ID. So we can then just return the representation of the newly added item, including that ID. ASP.NET Core Web API comes with a certain type of action results for that and a helper method. And that helper method is created at action. So we are using that method if we are creating a new item. And there are 3 arguments we are providing. The first argument is the name of the method that is responsible for retrieving one individual item. So that's getProduct. And that getProduct call expects an ID. Remember, usually that's part of the root. So in the second argument to the createAtAction method call, we are providing an anonymous object where we set the ID to the ID of the product that was just stored in the database. Well, and the third argument is the product itself. Let's see how this will be implemented in the IDE and then especially how that looks like when calling the new API endpoint. Here we go. HTTP post is the HTTP method of our choice, and then we implement public async and then task of, well, I could use iActionResult even, so that's the interface, which gives us even more flexibility when returning custom values from that method. But in our case, action result is just fine. And we could actually even do action result of product. And this is automatically suggested here. But getProduct is the incorrect name for that method. We shall call it postProduct, and it expects a product as an argument. If we allow that the user set every individual property of that product, that's a good approach. If, however, we have a more complex model and only certain select properties of that model shall be set, a specific model just for that endpoint would be a better choice to allow certain security implications like mass assignment or overposting. These are attacks where we only expect a few properties of an object to be set, but an attacker sends us more properties than that, so even properties that we think are safe and cannot be manipulated will be set. In our case, however, just providing here a product is a good approach, and then we can just take the product and then use the database context and add the product here, and then await a call of context save changes async, and then we return via our specific created add action helper method. GetProduct is our first argument, so that's the action name. Then we have our anonymous object with the product ID, and finally as the third argument, we have the product itself. And that's it. That's the complete implementation of the post product method. We will use Postman to test our endpoint. Sending a GET request to /API/products yields this list of 33 products. The number will be important shortly. And now I change this from GET to POST. The URI stays the same, of course, but thanks to the HTTP method POST, we say now we would like to add something. I'm setting the content type header so that the API knows that we are sending JSON or data in the JSON format. And then in the body, here I pick raw, and then I just peek how a product looks like and send the JSON representation for that. So I do not have to provide the ID, but I could provide a SKU, whatever, ABC123, and then a name like cool sweater, and maybe a price of $9.99. And then we also have our categories. And that's something that will not work right away, and I'll show you why. So you see here that the categories are not serialized thanks to the JSON ignore attribute we are using, but we still get the category ID. So how about we also set the category ID to 1, for instance, for the first category, so that we do have a category. Now we are sending this request, but we'll get HTTP 400 bad request. Why is that? The reason lies in our product model class, because we have our category there and we got that warning, non-nullable. And just by setting category ID, this virtual category property will not be set automatically. It will be there when retrieving the data from the data store, but providing category ID does not set this. And there are two approaches how we can fix that. We could either make the category nullable, but then on the other hand, in our model, we actually expect the category. But well, so this would be an approach. And the other approach would be to just disable those nullable checks. And I would say, in our case, I would probably say we make this nullable here, but on the other hand, we make this field required. So we say the category is a required property, so it has to be set, and that required attribute comes from data annotations. And we'll talk about validation of the model in the next video, actually. But before we do that, let's implement that change here, rerun the API, and then go back to Postman, hit send, and this time we got HTTP 201 created. We have a new item in our data store. It has the ID 34, and we had 33 before. So yes, that's a new item with ID 34. We can repeat that actually. And then we get 35. And all of the properties we set are there, including the category ID. So our endpoint works, and we then finally got this information here back, where we see the new item that was created. I would like to briefly talk about validation now. You have previously seen that we added the required attribute to our model for the category ID, but we can also use this for some other properties of our model class. So how about we use required for the SKU, required for the name, and required for the description. And as you are most probably aware, these data annotations also support other features, for instance, regular expressions, where the input has to match the regular expression, or the restriction that the property has to be within a certain range, and several others. So for instance, we could provide a regular expression for the SKU here, because so far it has been always 6 characters, if I'm not mistaken. But this will do for now. So let's see what this code change has an effect when we go back to Postman. I'm using the same HTTP post request as before, so I'm adding a new item with SKU name, price and category ID to our database. Or I'm not. Why? And I do get the validation error here out of the box. And the validation error is that the description field is required. Oh yeah, indeed. Now description is mandatory because I've used the required attribute, but I don't have a description here. That's perfectly fine, but this behavior can be tweaked a little bit. The reason why we get the HTTP 400 bad request response and the detailed error message in the first place is this, the API controller attribute. That's the reason why we get this. This is one of the benefits of using this attribute. But again, we can tweak this a little bit because you may know that when you're using ASP.NET MVC, for instance, and have an action method, and that action method receives data, that you have to more or less manually verify that the information is correct. So you have to, well, not really run the validation, because that's what ASP.NET Core is doing for us, but you have to check the result of the validation. So what we could do in, say, post product, we could do something like this. If model state is valid, and then we proceed as before, or if not model state is valid, we could do return bad request. I mean, we don't have to do this because we get the bad request anyway here if the description is missing. But in case that you would like to get informed about the validation error here, or want to add some proper custom error handling, that would be the way to go. But you have to tell ASP.NET Core Web API that you do not want the automated HTTP 400 when one of these attributes is violated. You can do this by going to Program CS, and here in the add controllers call, or to be precise, after the add controllers call, which enables Web API, you can append configure API behavior options. And then you can provide a couple of options. We only need one. We would like to suppress something. There are a few things you can suppress, but we would like to suppress the model state invalid filter. And then we put this in here, and just that we are able to verify that this worked, I put this in a comment, because otherwise we would still get bad requests. But I would like to show you the difference. Back in Postman, we run the same request again without a description, and this time we get HTTP 201 created, and the description, well, has a default value. It is now empty. But again, in those cases, you should have your own custom error handling to actually react upon the fact that the description is missing and your model says the description must not be missing. When updating items, we need to think about our strategy first. What kind of arguments do we provide? And here's what I recommend. We have an action method, and that action method is called putProduct because we're using HTTP put, and of course also the HTTP put attribute. The first argument is the ID of the product we would like to update, and we're using a route template here, as you can see in the HTTP put attribute. Also, we expect the actual product, the updated data, so to speak, and we expect it in the body of the HTTP request. So we have the ID and the product. And then what we essentially do is that we are setting the state of the entry of that product to modify it. And then we call, as you probably have already guessed, save changes, and we are done. The recommended return data for such an update is nothing. We are idempotent, so there's no information that could be returned from the server. So just returning nothing seems to be a good idea, and the no content helper method actually does that. Of course, some things could go wrong here. We have an ID for an article, but maybe that article doesn't exist. We would have an error condition then and probably could issue a bad request result. Also, saving data could be wrong, maybe due to a concurrency issue. Some other API call might have already changed the product at the same time. Also, the product that someone submits to that call could have a different ID than the ID in the URL. So there are a couple of cases where an error could occur and we need to handle them. Coding time. First, we restore the default error handling and model validation by removing our extra call from program CS, and then we go to our products controller and implement the new method. So HTTP put it is, and we expect the ID at the end of the URL, and then we implement our method, and our method will be public async task of action result, and I'll call it put product because we're using put, expecting an ID and the product. So far so good. And now let's start with the first error condition. So what happens if the ID is not equal to the product's ID? Well, in that case, we obviously have a bad request. So return bad request. Now we could actually try saving the data. So I'll do underscore context to access the database context, and then entry of product, and then state equals entity state dot modified, which basically says, okay, this has been modified. So next time we are doing something like save changes or persisting data to the data store, it will be updated. That's what we do next. So I use a try catch statement because something might go wrong here. And then I here just await context dot save changes async. We're still asynchronous. And then I could catch an exception, and there is one very specific exception I'm looking out for. It's DB update concurrency exception. That's the exception that occurs if there is a concurrency issue. As I've mentioned before, maybe the product has already been modified by some other API call. And there are actually two ways this could go wrong. One is that it just was changed. The other one is that it was deleted. So first I check if the product still exists. And if not, if it does not exist, then I have a different error handling than if it does exist, but there's a concurrency issue. So if not context products dot any, and then product ID is the ID. So if the product isn't there any longer, in that case, from a REST standpoint, this is 404, not found. We try to update something that doesn't exist, so return not found. Otherwise, we have standard error, so we just throw the exception, and then the HTTP 500 error will then probably be serialized into JSON. Otherwise, all is good, and we can return, well, nothing, so no content. And that's the implementation. We check whether the product has the same ID as the ID in the URI. Then we set the product to modified. We save changes, and if something goes wrong, we do some error handling. If all works according to plan, we just return no content, and that's it. Let's try this out in Postman. I am adding a description to my item. Cool and warm at the same time. And then I am using post. I'm adding it to the data store. So now I know product 34 with the ID 34 is my cool sweater. And now I'd like to update it. So I make a put request to /API/product/34. And then I just change the description, warm and cold at the same time. And maybe the price could also be updated to, how about $8.99, because it's a real nice offer. And then I hit send here, and then I get bad request because I'm not providing an ID here. All right. So I'm adding the ID, and the ID I'm adding, let's say we're using 33. Bad request because it doesn't match. So 34 it is. And now I get no content. So I have added the item first and then I have updated it. And I wanted to update it to warm and cold at the same time, $8.99. So I changed this back to get to have a look at product number 34 specifically. And indeed, warm and cold at the same time. And the price is $8.99. So our put endpoint works as expected. The final operation we are about to discuss in this chapter is the D in CRUD, delete. We would like to delete an item from our data store, which means that we need a method with the HTTP delete attribute. And we have to provide the ID of the product we would like to delete. We don't need the full product, just the ID is good enough. Then we have to get the product from the data store. And then the first question is there such a product? If not, we have to return HTTP 404 not found. On the other hand, if we do find the product, it's time to get rid of it. So let's just delete it from our database context and then save changes. One question remains. Which information do we want to return now once we deleted a product? I've seen various options here out in the wild, but the majority of APIs more or less agrees on returning the product that was deleted. You can argue now whether that's really required or whether no content would be good enough, but let's just stick with the majority and return the item that was removed from the data store. Time to hit the IDE. In the products controller, we add HTTP delete and use ID in the template for the route. And then we implement public async task of action result. And since we are returning a product, we could say action result of product. But that's not mandatory. Delete product, just expecting the ID, which comes from the URI. Then we retrieve the product. So we await context products find async of the ID from the URI. And if there's no product, then we return not found. That's typical HTTP 404. Otherwise, we go to the context and the list of products, and then we remove the product. Finally, we save everything. So context save changes async. We await it. And then we return the product as previously discussed. And that's already it. That's the complete delete product method. Let's try that out. I have prepared Postman to issue a post request, so we create a new product first. Remember, after restarting the application, the in-memory database is purged. Therefore, we are doing this. So we get a new product. ID is 34. So if I say get and then API products /34, I get the product back. And then I change this to delete. And actually, I don't need the body of the delete request because everything's in the URI. I send it and then 200. Okay. I get the item with the ID 34 back. But if I hit get again, then we get HTTP 404 in return, not found, because the product is gone. We just deleted it. So that was CRUD. Creating, reading, that was in the previous chapter, of course, updating and deleting items via our ASP.NET Core Web API. So far, our delete method does exactly what its name suggests. It deletes one product with one ID. How about we add an additional method that, well, actually deletes several products? So we provide several IDs and all of them are deleted. Let's go. As it is often the case, there's more than one way to reach a solution. Of course, we might just change our delete product method that it accepts, say, an array of IDs. However, then our routing would be messed up because we then cannot just append /ID to the URL, but we have to append a list of IDs somehow. Therefore, I just propose we add a new endpoint here. The implementation is relatively similar, so I do something I usually don't do. I use copy and paste. Well, sometimes I do. I have to be honest here, but don't do it. Unless in this very specific case. I'll call this method delete multiple. And it receives a list of IDs. And I would propose we put those IDs in the query string. So from query it is. So far, so good. I would feel more comfortable if this was HTTP post and not HTTP delete, because a delete request in our case just deletes one item, but not several ones. So HTTP post is what I'm using here. Also, I use a specific route for that. I use the route delete, not the HTTP verb delete, but the route delete. So we just append delete to the base URI of this API controller, which is /API/products. What I could then do is I could just iterate over all of the IDs. So doing something like this for each var ID in IDs. And then I just go ahead and delete the item for each ID. But what will happen if, say, someone submits 3 IDs, but the third one does not exist? I iterate over the IDs, I delete the first item, I delete the second item, and then I find out, oh, the third item doesn't exist, so maybe I should return not found. But I already deleted the first 2 items. And in my book, and of course you can have an opposing view here, but in my opinion, if one of the IDs doesn't exist, then not found is the only viable response of that action method without deleting anything, right? Because there is an issue with the arguments that were provided. So here's how we could solve this. I create a list of products and I'll store the products in that list. That will be helpful a little bit later. Then I iterate over the IDs. I look for each individual product. So I await context products.find async of ID. And if the product is null, so if the product doesn't exist, then I just return not found. Otherwise, I don't delete the product, but I store it in the list. So products add product. Next, we should discuss how the return value will look like, because previously with the delete call, we just returned a product, the product we deleted, but I think we should return off the deleted products in our new delete multiple call. And to simplify things a little bit, I just remove product here and we return a list. All right, so far so good. And what we now have is, and actually I can remove this call. What we now have is a list of products, and we would like to remove this list of products. And for that, Entity Framework provides remove range. So we are just removing all of the products we have in our list. Do save changes, and then we do not return the product here, but we return OK of products. So the HTTP 200 is returned with all of the products involved. Looks good, so let's have a look in Postman. Here in Postman, I first issued a call to the /API/products endpoint to retrieve a list of all of the products in our data store, running from 1 through 33. So let's delete a few of them. I'll convert this into a post request to /API/product/delete. That's the route we chose. Then we use the query string to provide the list of IDs. And how that works is that I have to provide integers, several of them. So I'm just using the IDs query string name a few times, and then ASP.NET Core Web API, or the model binding to be precise, converts that to an array of int. So I do IDs equals 1, and IDs equals 2, and IDs equals 3, and IDs equals 33. So I'd like to remove these 4 items. I hit send. I get 200 OK. And I see that ID 1, 2, 3, and 33 were deleted. And I then, of course, want to verify that. So back to the GET request to /API/products. And then the first ID is 4. And the last ID in the system is 32. So deleting multiple items from our list of products worked as expected. We have reached the end of our journey, but it's just the end of our journey together, because your individual journey will, of course, continue. At least I hope it does. And I already have a couple of ideas which topics might be of interest to add on to what you've learned so far. There are several topics where we just didn't have the time to cover them very much in depth, since our mission was to provide a good overview of what's possible and how to implement this. One of those additional topics is what I would like to call advanced data retrieval. So far, we have just pushed everything from the database to the client. So the API returned everything. But maybe the API would like to have features such as sorting, pagination, filtering, etc. So there are various approaches how to achieve this, and this might be a nice addition to our API. Also, APIs can be versioned. Imagine you have an API and people are using that API, and then you add something to it and find out that maybe it's not 100% compatible with what's already there. And one idea here is that you can just create a new version of your API, and then both of those versions are running, and clients can choose which version to use. ASP.NET Core Web API comes with built-in support for that. So that's, I think, a very valuable addition. Also, securing APIs is a big topic, and a topic with many, many different aspects. For instance, enforcing HTTPS or making the API friendly for JavaScript calls because there are some security mechanisms in place, or using token-based authorization or authentication for your API. Lots of topics which are covered, and all of these 3 topics will be covered in the upcoming Advanced ASP.NET Core Web API course. Also, another topic we just briefly mentioned, but of course there's so much more to discuss here, is API design. So how you can make your APIs even more RESTful and therefore maybe more predictable and or friendly to use. And since I've already mentioned security, the whole topic of ASP.NET Core security is very, very important. Web-based applications are available 24/7, so they can be attacked 24/7. So knowing about various security risks and mitigations with ASP.NET Core is paramount, and therefore I encourage you to also invest in that subject. And with that, thanks again for tuning in, and I hope you enjoy creating your APIs with ASP.NET Core.